We're going to be talking about basic compounds, which includes ionic compounds, and covalent and polyatomic. Alright, an ionic compound, a positively charged cation and a negatively charged anions. For example, sodium chloride or salt. A cation is any group or group of atoms with a positive charge. An anion is any atom or group of atoms with a negative charge. Are there different charges? Yes, there are. We're going to first talk about atoms with one charge and then multiple charges. So, atoms with one charge is metals in the group 1 of the periodic table, which is right here. And group 2 typically Group 1 of the periodic table typically form +1 charges. Group 2 typically form +2 cations. In addition to group 1 and 2 metals, aluminum is a +3, zinc is +2, and silver is positive. So I like to go by this handy chart. Basically, in the first group, you have a +1. Second group, you have +2. You're skipping the transition metals, and then you go to the row with aluminum, and you have +3. Then with carbon, you have plus or minus, which could be +4 or -4. Then you have -3, -2, -1, and then 0, obviously, at the noble gases, because they don't have... Yeah. And this is caused due to a lack of a full valence shell. A full valence shell is 8 electrons, but I don't know if you know this. Alright. Multiple charges. Most transition metals form more than one common ion. Iron 2 and iron 3, which look like this in word format, is Fe+2 and Fe+3. Copper 1 and copper 2 ions, Cu+ and Cu+2. Gold 1 and gold 3 ions, Au+ and Au+3. Nickel 2 and nickel 4 ions, +2 and +4. Main heavy group metals may also form more than one cation, such as tin 2 and tin 4. Sn+2 and Sn+4, lead 2 and lead 4 ions, Pb+2, Pb+4. Alright, well, how do you actually make a compound? Well, you use the crisscross method. So, if you have one, say you want to combine sodium and oxygen. Now, sodium tendency has a +1 charge, and oxygen has a -2 charge. Now the way you do it is you just put the 2 here and the 1 here. So Na2O1. You don't put the 1 as a subscript though. Alright, Pb+4 and O-2, again, Pb2O4, but this can be reduced due to 2 and 4, so it can be divided by 2. And so you get PbO2. Alright, what about, these are all even, or close enough. And it still works with magnesium and nitrogen, for example, with +2, -3 goes to Mg3NO2, Now, ionic is this stuff, because it's a metal and a non-metal. Metal, non-metal, metal, non-metal. Now, covalent is a non-metal and a non-metal. Now, when you write this out, so like this is sodium oxide, now if it was covalent, you'd have to use a prefix. And because there's 2 sodium ions, it would be disodium oxide, and you also add IED to the end, to the second name. And mono is 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Example of this, carbon dioxide, CO2. Polyatomics, you do the same thing with crisscross. As you can see, these are just a list of common polyatomic ions, and they basically are the same thing. I hope that makes sense for basic compounds. Thank you for watching. Have a nice day.